People tend not to be worried about nuclear radiation used for medical imaging or for cancer treatment, even though the doses for cancer treatment are huge compared with background radiation, which also tends not to worry people. Nuclear power is only about half as popular as other low-carbon methods for generating electricity, such as solar and wind. People who are against nuclear are mainly concerned about expense and safety, particularly nuclear accidents and nuclear waste. The best scientific evidence is that the Chernobyl reactor meltdown will cause fewer than 200 deaths over a period of 60 years. The earthquake and subsequent tsunami that caused the meltdown at Fukushima in Japan killed at least 20,000 people, but with 0 deaths from radiation, despite widespread contamination of the local area. So even though nuclear seems as safe as many other low-carbon methods for generating electricity, it still has a bad rep. Here are some of the most common concerns about nuclear power. No one knows what to do with the nuclear waste. To dispose of the most radioactive waste, it's made into solid blocks and placed in sealed, engineered chambers deep in the bedrock. This keeps it away from people. To be extra safe, the solid waste is encased in strong metal sleeves, and a site is chosen that's very dry and not subject to earthquakes. The waste will be lethal for hundreds of thousands of years. As we've seen in Lesson 5, very long half-life means very low radioactivity. The most hazardous isotopes in waste have half-lives of about 30 years, since they're significantly radioactive for a human lifetime. But these lose 99.9% of their radioactivity within the first 300 years. The waste containers will eventually fail and the waste will leak out. High-level waste is always disposed of as a solid. The waste is like the green pigment in this glass. The green can't leak, even if the glass is broken. The radiation might still drift up to the surface eventually. Remember our sparkler analogy. If the sparkler doesn't move, then the sparks can't travel any distance. In the same way, radiation can't travel long distances, only waste, and that's a solid that doesn't dissolve in water. But people don't use facts and reason when they decide whether to accept a risk or not. They use these 3 rules of thumb instead. 1. Who is offering me this risk? Because if I think they're bad people, then I'm not going to accept any risk, no matter how small. 2. What's the personality of the risk? If it's something that's scary, artificial, invisible, and controlled by people I don't trust, then I don't want to accept the risk. And 3. What precautions do I see people take? Why would you put waste hundreds of meters underground in incredibly strong containers and talk about safety the whole time, unless it was really dangerous? These 3 rules of thumb are all rational, but they aren't really scientific. Where do you sit? Do you believe the science, or does it just still sound too worrying?